Hey, science students, it's Mrs. Gnage. Welcome to Gnage Virtual Science. Today's video is going to help us reach our goal for this week, which is we want to be able to explain the principles of what scientists use in order to estimate the age of Earth. They use these principles to talk about Earth's history and talk about past events, talk about how our climate has changed over time from ice ages to mass extinctions to the dinosaur age, all those different things. So today we're going to be focusing on a specific principle called relative dating. And no, I'm not talking about asking your cousin out on a date to the movies. We're not talking about dating those kind of relatives. No, we're talking about relative dating. And the basics of relative dating is saying whether or not something is older or younger than something. So if we were in class right now, I'd be asking you, are you older or younger than Mrs. Gnage? And you would probably say you are younger than Mrs. Gnage. Now, that doesn't say how old I am. It doesn't say exactly how old you are. It just says relative to each other, you are younger, I am older. Okay, so that's kind of the idea of relative dating. It doesn't give an exact age to something. It just compares two events. One event was older than the other, one event is younger. One fossil's relatively older than the other, one's younger. Doesn't say an exact age. So that's what we're going to be talking about today, relative dating. Okay, so in order for relative dating to work, in order for scientists to use it as a way of talking about Earth's history and know if certain things are older or younger, they have to use this process, and I could barely fit it on an index card. Uniformitarianism, okay? It's a big word. It's like supercalifragilisticexpialidocious. So uniformitarianism. You're going to recognize the first part of that because you all wear one, a uniform. When we all wear a uniform, we are all dressed the same. And so the idea of uniformitarianism is that the same processes that are happening around us today, we need to accept that those same processes happened in the past. For example, if rock is weathered by wind and rain today, then 100 years ago, wind and rain must have weathered rock. If sand is eroded today off of a beach by water hitting it, then 1,000 years ago, sand must have been eroded off of a beach through wave action. Okay, so basically uniformitarianism, uniform, same, means that the same processes that happen today happened in the past, okay? So, and it happened in similar ways. So weathering, erosion, deposition, rock depositing and layering, things that happen today happened the same in the past. So in order for us to talk about relative dating, we need to reference that things that happen today happen the same way in the past, okay? So that's uniformitarianism. Okay, so let's talk about how relative dating works. Again, relative dating is just saying whether or not something is older or younger than the other event or object. So I brought out my snack. We just had snack time inside with Colin. So I brought out my snack to help talk to you about how this works for scientists. And there's actually a law that scientists came up with, the law of superposition. This is like the video of big words, okay? So the law of superposition. And so I have for you a snack that I made. It's a peanut butter cracker with some marshmallows. And in order to make that snack for Colin, I had to do it in a specific order or it wouldn't work, okay? So in order to make a peanut butter cracker with marshmallows on top, the first thing I needed to start with is the cracker. Okay, I can't start with the peanut butter, okay? And here's why. I can't have a layer of peanut butter and then add my cracker to it. It doesn't work that way, okay? And so when you're talking about rock layers forming, there has to be a particular order that they form in. You can't layer the middle layer first and then go back and layer underneath and layer on top. It has to go in a particular order. So the law of superposition states that the bottom layer is the oldest, is the one that was layered first. Then another layer comes on top, and that one is younger than the one on the bottom. And then another layer, my marshmallows, come in on top. And the marshmallows are the last thing that layered here. So the marshmallows are youngest because they are on top. So when you look at rock layers, if you look at the Grand Canyon and you look at all those layers, okay, of rock, okay, the one on the bottom is the oldest layer. It had to have been layered first in terms of events. It has to have been because in order to get the ones on top, that one has to be there first. And then the one all the way at the top, that's the youngest layer. That one layered last. So that's the basics of relative dating. Scientists can go look at rock layers and know which one is older or younger based on which layer is on the bottom and which layer is on the top. Again, that is the law of superposition. Now, relative dating isn't an exact way of dating Earth's history because there's lots of things that happen that mess with rock layers, and those are called unconformities. And it kind of messes with the data. It skews it. It gives you some gaps in Earth's history or the rock layers that don't make sense. For example, let's say you have a layered peanut butter cracker, okay? And the cracker was the oldest layer because that came first. Then you have some peanut butter, and that's younger because that came on top. Well, then you have plate tectonic action squishing those rock layers, and all of a sudden that rock layer gets squished and folded like that. Well, now, all of a sudden, this older layer that was once on the bottom, see, it was once on the bottom, is now pushed and folded on the top. And so you would think that this layer is younger because it's now on top. But really, it's the older layer because it was down on the bottom. So sometimes that messes up with data. Weathering and erosion can mess up rock layers. So I have, again, my peanut butter crackers, okay? So if I look at this one, the marshmallows are on top, suggesting if they're on top, they're the youngest layer, right? But if I walk over here to this area, this peanut butter no longer has marshmallows on top. Why? Because they were weathered and eroded away, that layer. So now in this area of the world, the peanut butter is suggested as the younger layer because the other layer got weathered and eroded away. So I've got some interesting data here that doesn't match up. And so scientists have to be careful and study the unconformities to really see which layer in their rock layers is oldest and which layer is youngest. Okay, so let's go back and look at your activity from yesterday, talking about the dried mud puddle, okay? This was an example of doing relative dating. Why? Because what you were doing is you were sequencing the events in order relative to each other, meaning this one happened first, this one happened second, this one happened last, okay? You weren't saying this happened on this such a date at this time. You were not giving an exact date to it. You were just saying the order of events based on each other. This one had to have happened first, this one had to have happened next. And so in looking at the dried mud puddle, okay, in order to put the first event first, you're going to say, well, in order to have a mud puddle, you have to have rain. So the first event that I would justify is the thunderstorm began, because in order to have, again, a mud puddle, you need to have water, rain, okay? So that would be the first event, okay? Next is if you look at the footprints, right? There's a hailstone and some cracks through the footprints. So if you are going to put a hailstone image or print on a footprint or crack the footprint has to be there first, people, okay? You can't like crack and then put a footprint on it afterwards, okay? So the next event, the thunderstorm began, the next event would be a child ran through the mud puddle, creating the footprints, okay? Now, afterwards, the hailstones then fell, okay? I put that one next because in order for it to leave an imprint, there still has to be mud there. And the next events talk about the mud puddle drying up, okay? So that's how I'm sequencing them. I'm putting them in order relative to each other. What would have happened first? What would have happened next? So I have a thunderstorm began, which would have created the mud puddle. A child ran through the mud puddle. The hailstones then fell. The mud puddle then dried, okay? The last event I have is the sun dried the mud puddle, causing the cracks to form, okay? So in order for the sun to form the cracks, the mud puddle has to dry up. So that's why I sequenced them that way. This is an example of relative dating because we are just comparing the sequence of events to each other. We're not giving an exact date of when the event occurred and what year it happened and what time it happened. We're not doing any of that. Relative dating is just saying something happened first, then something happened afterwards in comparison to each other. So I want you to go back and think about your scavenger hunt. You found something in your house yesterday, okay? Do you think you gave me the relative age of it in comparison to something, or do you think you gave me the exact age? Okay? Those are the two things that scientists do. They talk about relative dating, but then they also talk about absolute dating, giving an exact age to something, an exact time. Okay? That's what we're going to talk about tomorrow, is absolute dating. So think about your scavenger hunt. Did you find the relative age of your object? Did you compare it to something and say this must be older, this must be younger in comparison to something? Or were you able to give the exact age of it? So think about that and have a great day. I'm going to finish my snack.